Good afternoon. I want to take a minute to go through the Understanding pH worksheet. I know that some of you had requested this, that you were having a little trouble understanding how to work the calculations and what all of it meant. So I'll take a little time to go through what the logarithm is and why we use that when we're looking at pH. So I'll share my screen here for you. Okay, so we're going to look at a few things about pH. So first of all, when we look at pH, pH is a measure of the hydrogen ion concentration. So when we see this H plus here, that's the hydrogen ion, and these brackets around it mean concentration. So you're going to see that a lot as you look at these calculations, but that all it means is the concentration. Now recall that when we looked at Arrhenius and Bronsted-Lowry acids, we noticed that hydrogen was a key component. So we know that hydrogens indicate acid. So if we have a high number of hydrogen ions, so a high concentration of hydrogen ions, then that is going to equal, oh, my pen's going a little crazy here. I don't know what's happening. Okay, let's try again. Sorry about that. Okay. And we know that an acid has a low pH, so a high hydrogen ion concentration equals a low pH, which equals an acid. Okay. Now, when we looked at Arrhenius bases, we saw that Arrhenius bases had an OH. They had hydroxide ions, not hydrogen ions. So if we have a low concentration of hydrogen ions, that indicates a high pH, which is a base. And another way to say this is if we have high hydrogen ion concentration, then we have to have a low hydroxide ion concentration. And down here with our bases, if we have a low hydrogen ion concentration, then our hydroxide ion concentration is going to be high. We're looking at just Arrhenius bases here so that we can kind of get this concept. Now, the pH scale, we know, goes essentially from 0 to 14, where 0 through 6 is an acid, 8 through 14 is a base, and 7 is considered neutral. Okay, but why is that? Why are those values set up the way they are? Well, that comes to what we refer to as the Alto ionization constant for water. So Kw is a constant, okay? It's the Alto ionization constant of water. Okay. Now, remember, water is HOH, right? And so water can be both an acid or a base. So the ionization constant of water is a measure of the hydroxide ions times the hydrogen ions. And it is equal to 1 times 10 to the negative 14. Okay, so the Alto ionization constant of water, which is the hydrogen ion concentration times the hydroxide ion concentration, is equal to 1 times 10 to the negative 14. That's where the 14 comes from on the pH scale. Okay, Now, if these are equal, then each one would be equal to 1 times 10 to the negative 7. So when hydrogen ions and hydroxide ions are equal, then that gives us a pH of 7, okay? Because they're both the same. So if you cut that in half, 1 times 10 to the negative 7, we take the log of that, it gives us 7, all right? So what does that mean, take the log of that? Well, the pH is a logarithmic scale. Okay, and what that means is as we go through 1 to 14, or really from 0 to 14, each step is not just a power of 1, it's a power of 10. Okay, so if we have a pH of 1 and we go to a pH of 2, then that's 10 times less hydrogen ion concentration. Okay, if we go from a pH of 1 to a pH of 3, don't know why it is doing that. Okay. pH of 3, then that's 100 times less hydrogen ion because it's 2 steps. So it's 10 times 10, 100 less. And that's because it's a logarithmic scale. A logarithmic scale is based on powers of 10, okay? And really, you're looking at exponents. Okay, so if you look at your understanding pH sheet, you have this activity that says, what is a log? And it says 2 to the x power equals 8, find x. Okay, so basically we're wanting to know, to what power do we have to raise 2 to get 8? Well, it's 3, because 2 times 2 times 2 is 8. Okay, so if we look at more complicated problems in which pH problems are kind of complicated, then we can say 10 to the x power equals 1,000, where x is equal to 3, because 10 times 10 times 10 is equal to 1,000. That can also be expressed as log of 1,000 equals 3, and you see the little box there, it says the power to which 10 must be raised to equal 100. Okay, so the logarithm is, to what power must 10 be raised to equal this bolded number here? Okay, so you're going to practice putting these in your calculator. Now, some calculators are different than others. In some calculators, you just put it straight in. So on that first one, you would just put log of 10. And that's going to be 1. If we raise 10 to the first power, we get 10. Okay? But some calculators, you may have to put in 10 log equals. So you need to play with your calculator to get that answer, log 10 equal to 1. Okay? Now, the next one says log of 1. Now, if you're using your calculator on your phone, then you want to make sure you're in scientific mode. And Apples and Androids are a little bit different. Again, you're going to have to play around with your calculator to know exactly what way to put this in. So if we put in log of 1, that equals 0. Okay, so 10 to the 0 power is 1. Okay, log of 100 million. And again, play around with your calculator to figure out exactly how you need to put this in to get the right answers. And that's equal to 8. And what that means is 10 to the 8th power is 100 million. Now we can also go backwards. Okay, log 0.001. -3. And so that says 10 to the -3 power is equal to 0.001. So we can have positive powers, we can have negative powers, okay? So logarithms allow us to manipulate hydroxide ion concentration and pH. Now, if we look at log of 1.0 times 10 to the -8, you're going to want to make sure you get that in your calculator correctly. In my calculator, I have to use parentheses, and you may have to do that on yours too, but you want to make sure that you get that in there correctly. Now, if I take the log of 1.0 times 10 to the -8, it's going to be -8, okay? So make sure you get that. Now, if we look at the next problem, log 650. The number 650 is between 100 and 1,000, so the answer must be between blank and blank. Well, the log of 100 is 2. The log of 1,000 is 3. So I know that the log of 650 has to be between 2 and 3. Okay. Now, I'm going to put that in my calculator, and I'm going to get 2.81. Now, here's something to remember about pH or logarithms. Anytime you do these pH problems, all of these pH problems, you want to go to 2 decimal places. Okay, so we're going to go to 2 decimal places for all of our pH problems. So for the log of 650, it's 2.81. Okay. Now, right there, you need to put the directions for how to enter that in your calculator so that you know. Okay. Now, we've already given one formula that's important when working on pH problems. We said due to the ionization constant of water that we can multiply hydroxide concentration and hydrogen ion concentration, and that is equal to 1 times 10 to the -14. So that's an important formula that you need to know. Now, we also can look at this. pH is equal to the negative log of the hydroxide ion concentration. pOH is equal to the negative log of the hydroxide ion concentration. Okay. And because we know the max pH is equal to 14, if we add the pH plus the pOH, it can't go over 14. Okay, so it's going to be somewhere between 0 and 14. So the other thing I want to point out to you is that sometimes you see this. Okay, that's hydronium, and it is the same thing as the hydrogen ion. Okay, so those are the same thing. So if you see H3O plus, don't get freaked out about that. It is just the same thing as the hydrogen ion. Okay, so you may see pH equals negative log of H3O plus, same thing. So don't be weirded out. Both of those are the same thing. We can use those interchangeably. Okay. Now, the other formula that I'm going to give you that we're going to discuss in just a minute is that 10 raised to the negative pH power is equal to the hydrogen ion concentration. So this slide is important. This has all of your formulas on it. That's called an anti-log, but we'll get there in just a second. So let's look at the very bottom of page 1 on your calculating pH there, they want to know the pH when our hydrogen ion concentration is equal to 2.6 times 10 to the negative 6 molar. Okay, remember mole is just a unit of concentration. Okay, so we're just going to figure out what is pH when H is equal to 2.6 times 10 to the negative 6. Well, we know that pH is equal to the negative log of the hydrogen ion concentration. So I'm going to say negative log 2.6 times 10 to the negative 6. Okay. And again, you need to make sure you know how to put this in your calculator, and don't forget about that negative sign in front. If you get a negative number, then you've done something wrong, because the pH will never be negative. Okay? So if you get a negative number, I'm just going to kind of write that down here. If you get a negative pH, it's wrong. You won't ever have a negative pH. So in this example, my pH is 5.59. Remember, I'm going to go to 2 decimal places. Okay. So at the top of page 2 on your Understanding pH worksheet, you've got 2 problems that are exactly the same as this one, just with different numbers. Okay. And then you've got a little fill in the blank here. The blank, the hydrogen ion concentration, the blank, the pH. Well, that was back on my very first slide that I showed you here. The higher the hydrogen ion concentration, the lower the pH, or the converse of that. The lower the hydrogen ion concentration, the higher the pH. Okay. Now, when I look at the next section, acidic or basic, we've kind of went over this also on this this slide that you're looking at here. When hydrogen ions are greater than hydroxide, solution is acidic. When hydrogen ion is less than hydroxide, the solution is basic. When they're equal, the solution is neutral. And it said find the hydrogen ions in a neutral solution using the equation for Kw. Well, like I showed you here, that when they're equal, our solution is neutral. But how do I know that? Well, I know that because if these are equal, then I can assign them as a value of x. Okay, we can use x to represent them, and we only need x because they're the same. So that's the equivalent of saying x squared is equal to 1 times 10 to the negative 14. And so if I just take the square root of both of those, okay, so if I go in and I take the square root of x squared, then I know that's going to be equal to x, which can equal either my hydrogen ion or my hydroxide ion. If I take the square root of 1 times 10 to the negative 14, then I get 1 times 10 to the negative 7. Okay? So my hydrogen ion concentration in a neutral solution is equal to 1 times 10 to the negative 7. And the pH is 7, because if I take the negative log of that, I get 7. Okay? So we've got some other fill in the blanks here. When pH is less than blank, the solution is blank. Well, when the pH is less than 7, the solution is acidic. When pH is greater than 7, the solution is basic. And when pH is equal to 7, the solution is neutral. Okay? Now, the next thing that's here is what we refer to as the antilog. Okay? And this is that other formula that I wrote there for you. 10 to the negative pH is equal to the hydrogen ion concentration. Okay, so this is what we refer to as the antilog. So if we have the pH equal to 4.97, I'm going to say 10 to the negative 4.7 power. Now, your calculator maybe a little different on how you do this. Okay, so I'm going to put this in my calculator, and I can just write it exactly how it's written, and I get 0.0000107. So 1, 2, 3, 4, 5. I'm going to say 1.07 times 10 to the negative 5. Okay, and that is my hydrogen ion concentration. So then you need to write the directions on how you enter that in your calculator. So you may just enter it just like I did, 10 to the negative 4.97. You may have to put it in the little caret sign. You may have to put the 4.97 in first and then hit the negative sign. So just play around with your calculator and figure that out. Now, the last page, you've got practice problems here, okay? And what you're going to need are these different formulas, okay? Like in the first one, you've got the pH, you need to find pOH. Well, if you've got the pH and you need to find pOH, then you can use this formula right here. Just rearrange it and solve for pOH. The next one, you've got the hydronium ion. Remember, that's the same as your hydroxide ion, or I'm sorry, your hydrogen ion, is 8.20 times 10 to the negative 9. Find OH. So you've got the hydrogen ion concentration. You need hydroxide ion concentration, so you're going to have to use that formula. Okay, again, just rearrange it. Number 3, you've got the hydronium ion, again, same thing as your hydrogen ion, and you want to find pH. So you'll use that one. Okay, you've got hydroxide ion concentration, you want to find pOH, well, we'll use that one. Okay, so you're going to use all of these different formulas, and let's see what else. You've got pH, you're going to use that one too. Okay, so you're going to use all of these different formulas on that third page. Okay, and they're written at the top of that page for you, but they're also all right here. So you're also going to have these on your Unit 5 assessment. So the big thing here, it's all calculator work, okay? The big thing is just making sure you know how to enter it in your calculator. That's the important thing. Because if you know how to do that, then you'll be fine. Now, the last thing I want to mention is your lab that you had this week. So on the 11B lab, okay, I gave you pictures of what the titration looked like. Now, a titration is done when we don't know the concentration of either an acid or a base. In this example, we didn't know the concentration of the acid, but we knew the concentration of the base, okay? So we titrated with that base until we hit the peak endpoint, okay? That's a titration. And what I showed you, or what I gave to you in those pictures, is the volume of base that was left. All right, so on your data sheet, you have this table. Okay, and you had, the first one was the volume of the base that you started with. Well, in both of those, I started with 50 milliliters. Okay, and then you had how much was left, and I showed you pictures, so you're going to get that amount from those pictures. That was the volume that was left. And then you have volume of the base that was used. So you're going to take the 50 you started with and subtract the amount that was in the picture. This is trial 1 and this is trial 2. And then you had a little box right here that says average. So whatever you get here and here, you're going to add those up, divide by 2, and that's going to be your average. Okay. Then you had the volume of acid. Well, we started with 3 milliliters of vinegar. And then the concentration of the base was 0.10 molar. And then you were given a formula. Oops. Where M1, basically M1V1 equals M2V2. And you've seen this before when we were doing molarity. We've replaced the 1 and the 2 with A and B to represent acid and base. Okay, so we are trying to solve for molarity of the acid. So you're going to say molarity of the acid is equal to molarity of the base times the volume of the base divided by the volume of the acid. Okay, that's what that's how we're going to solve this. Now, you've got each one of these. Okay, so the concentration of your base, that is the molarity of your base. Okay, the volume of acid, of course, that's volume of acid. And then the volume of the base used, you're going to use this average here, and that's going to go right there. Now, you are going to have to make a change. Okay, this volume is in milliliters. This volume is in milliliters, but mole here, remember, is in mole per liter. Okay, mole per liter. So you're going to have to convert these volumes to liters. Okay, so before you plug those in, you need to make sure you convert those to liters because your molarity is in mole per liter. If you do not convert these to liters first, then you're not going to get the correct answer when you solve for molarity of your acid. Okay, so that is Lab 11B. That's how you do the calculations on that particular data sheet. So I hope this has helped you understand the math behind pH, and that you'll have now some resources to be able to complete this worksheet and also complete the Unit 5 assessment.